Hi, this is Ms. Jensen, and today we're going to talk about transforming generic functions. So a generic function is just nothing that really follows any kind of an equation. So it's kind of a funky looking graph. We're going to do it pretty much the same way we do when we're given an equation. Usually when we're given an equation, we make a table, and then a lot of times we transform the table. We're going to do the same thing here. You can also just take the original graph and do what it tells you. Like in this case, because it's on the inside, it's going to do the opposite, and it's going to be a horizontal. This is going to be a horizontal shrink of 2. So we can kind of see that ahead of time. Okay, so the way we're going to do that is we are going to pull points from the original graph. So if I look at this point is left 7 up 1, so I'm going to make a little table. Left 7 up 1. Next point here is negative 3, 3. This is right 1 up 3. Right 5 down 1. And the last point is right 7 down 1. Okay? So we're taking all the points where the graph seems to change directions and also the beginning and the end. Okay, so I'm going to look at what it tells me to do. It's going to be the opposite of the x's. So instead of multiplying by 2, I'm going to divide by 2. So negative 3 divided by 2. 1 divided by 2. 5 divided by 2. 7 divided by 2. So now we've replaced the x's with that. And now we're going to plot that. So I'm going to go left 3.5, up 1, left 1.5, up 3, right half, up 3, right 2.5, down 1, right 3.5, down 1. And we'll connect the dots. Okay? And it should look like the same shape, but just that it's been shrunk horizontally by 2. It's half as wide. That's pretty much what it looks like. Okay, we're going to look at the domain and range of both of these as well. So the domain is the x's. And I'm writing it like this because the graph ends on the left, it ends on the right. It ends going down, it ends going up. Okay, so as far as where does it end going to the left? Well, it's ending at negative 7. Where is it ending on the right? It is ending at positive 7. So the x's are between negative 7 and 7. The y's, if I'm looking up down, it goes up to 3 and down to negative 1. Up to 3, down to negative 1. Now we can see that on the original table as well. So if you look at this original table, you can see that the x's, if you look at the x's, the lowest number in the x table is negative 7. The highest number in the x table is positive 7. If you look at the y's, it goes down to negative 1, up to positive 3. Now here, if we look, and again, this is a little harder to see on the graph, but on the left it goes down to negative 3.5, it goes up to positive 3.5. So that's our domain. And our range is up, down. So what are the upper and lower limits? So in this case, it's the same. It goes up to 3 and down to negative 1. You look at the graph above. Okay, so once again, we're going to take critical points, now this is the same graph. So it is negative 7, 1, negative 3, 3, 1, 3, 5, negative 1, 7, negative 1. This time, the graph isn't having any kind of a horizontal stretch or shrink, or vertical for that matter. It's going right 1, up 2. It's doing the opposite to the x's, so instead of minusing 1, we're adding 1. And the y's, it's going to go up 2. Oop, try to get that 2 in there. All right, so now this is our new graph. And if I plot that, I'm going left 6 this time. 1, 2, 3, 4, 5, 6. And up 3. 1, 2, 3. Get rid of this here. Left 2, up 5. Right 2, up 5. Right 6, up 1. I think my smartboard is off a little bit, but hopefully you get the idea. Right 8, up 1. Okay, I'll connect those. And the graph should look like it's the same size. It wasn't stretched or shrunk. It just slid to the right 1 and up 2. Okay? So again, if I look at my x's, I can see it both on the graph and the table. Well, if I look at the table, the lowest is negative 6, the highest is 8. If I look at the graph, I can see the same thing. It goes to the left 6, to the right 8. If I look at the table here, I can see it goes down to 1 and up to 5. That is the y's. I can also see, looking at my graph, it doesn't go any lower than 1, it doesn't go any higher than 5. Okay, we're going to look at one that has arrows. So the main difference with a problem that has arrows is that it doesn't have a beginning and an end. I still want to plot the critical points where the graph changes direction. But I also want to include a point on the left or the right of that. So any point to the right of 0, 4, these are all nice points. Maybe I'll just pick this here. Going to the left, if I pick kind of a nice point, maybe I'll pick that, because it's going through 3. So just any point to the left and to the right, so we know what direction that arrow is going in. And then I'm going to make a table with those. So my first point here is 1, 2, 3, 4, 5, left 5, up 3, left 1, 2, 3, 4, and 0, 0, 4, right 2, up 4. Okay? Now this graph here looks like it was a vertical stretch of 2. So it should be of 2. Try to squeeze that in. And it went left 3. Okay? So I'm going to transform my graph here. I will take my y's and I will multiply it by 2. So this is 6, 0, 8, 8. And here I will subtract. That's supposed to be subtract 3. Okay? And I'm going to plot those points. So it looks like this is going to come off the graph a little bit. 1, 2, 3, 4, 5, 6, 7, 8. And if I go up 6, 1, 2, 3, 4, 5, 6, something around here. Let's see, 1, 2, 3, 4, 5, 6, yeah. Something like that. Negative 7, 0, 1, 2, 3, 4, 5, 6, 7. Negative 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. And negative 1, 8. Ugh. Make that a little more even. All right. Now if I connect these, because there's arrows on the ends of the original, I'm going to put arrows on the ends of these as well. Okay, so it should look like the same graph, looks like pretty much the same shape, but it should look like it's stretched twice as tall, which that's what it looks like, and it went left 3. Okay? So this is what the domain would look like. So the domain of this one here, because it has no left limit and right limit, so it does not stop going to the left, it does not stop going to the right, we're going to say the domain is all reals. Whereas the range, if I look, does it stop going up? Does it stop going down? Well, it does stop going down at 0, but it does not stop going up. So the y's are just anything greater than or equal to 0. We can say the same with this one here. I guess we better pull it down. So this one, it does not stop going to the left. It does not stop going to the right. It's going to continue going, 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 going. So your domain is all reals, but your range bottoms out at 0. It's going to keep going up because of this. It's going to keep going up, but it does bottom out at 0. So we're going to say this is all reals, and the range is greater than or equal to 0. Okay, we'll look at one more. So again, same one, it's 1, 2, 3, 4, 5, negative 5, 3, negative 4, 0, 0, 4. I'll pick any point. So again, I guess I'll pick the same one. Just a nice point to the right. And I'm going to do the opposite to the y. So instead of multiplying by negative 1, I'm dividing by negative 1. I know it comes out to be the same anyway, but technically we are dividing by negative 1. And it's going to go 2 to the right. So this crosses off. Right 4, up 2, 6. Okay. So again, if you think about what's happening here, I know it looks a little funny. It's like we connect this, but remember, it's going to keep going on both ends. Try to connect that if I can. Oh no, I won't connect it. Well, just you pretend that's connected. But it's going to keep going to the left. It's going to keep going to the right. This is it's really a reflection over the y-axis. It's almost a, again, a horizontal reflection. It reflects right, left. So this is flipped or reflected over x-axis, and then it's just up 2. And that is what it looks like it did. It does look like it did a right-left flip, almost a horizontal flip, and then it went up 2. Okay, and as far as domain and range, this is all reals. It does keep going up, but this time it bottoms out at 2. It does not go below 2, so the y's are greater than or equal to 2. And that is how you transform a generic function. Have a great day.